Pay close attention, because in this video, I'm going to explain how we can determine the equation of a line in its point-slope form and in its slope-intercept form. You'll see that it's super easy. Let's get started. Here it says exercise number 4, since in previous videos I already did exercises 1 through 3. So if you haven't seen them, I recommend you watch them too, so you can follow along in order. Alright, so the exercise says, find the slope and the equation of the line that passes through the points P, -1, 1, -2, and Q, -8, 8, 3. Alright, so the first thing we're going to do is determine the slope. Now to find it. For the slope, we're going to use the following formula. We're going to say that the slope is equal to y2 minus y1, and this is going to be divided by x2 minus x1. Where are we going to take these points from? Or, well, these values. It's very simple, from the coordinates. So if this is your point number 1, then this is x1 and this is y1. If this is your point number 2, then this is x2. And this is y2. So it's pretty simple, right? All right, let's substitute. It says, let's put y2, that is y, from point 2, which in this case will be 3. Let's put it. Done. Minus, we put it. y1, what is y1? Well, y from point 1, which in this case is -2. So I put a parenthesis and enter -2. I use the parenthesis because here we have a minus and then another minus. Then it continues. Over x2, which is x from point 2, so it's -8. Then we have minus from the formula x1, which is x from point 1, which is -1 done. Let's simplify a little here. Here I have 3 minus -2. That would be the same as 3 plus 2, right? So in the numerator, we're going to have 3 plus 2. And in the denominator, we have -8, we write it down. And here we have a minus 1, which is the same as plus 1. Let's continue. 3 plus 2 equals 5. And in the denominator, we have -8 plus 1, which is -7. Well, that's already the slope. But since we know that a positive divided by a negative is a negative, let me just put the minus sign at the beginning, and we'll just leave it as 5/7 done. So now we have the value of the slope. This value is extremely necessary because in the point-slope equation, as the name suggests, we need a point and we need the slope. All right, let's write the structure of the equation of our line in its point-slope form. That structure is as follows. Let's write y minus y1 equals m times x minus x1. This is the structure that we have. So let's just substitute. Look, in this case, we can choose to use this point or to use this point. The truth is that it doesn't matter which one we use. In the end, both equations we get will be correct. And anyway, we're going to see that right now. All right, in this case, I'm going to take point P first. Okay, pay attention here. If I take point P, I get y. Let's write it down. Minus y1. But how much is y1 I'm taking this point? Well, it's -2. So I would have y minus -2. But subtracting -2 is the same as adding 2. So I'm getting y plus 2. Are we on the same page? It's y minus 2. It would be the same as y plus 2. Okay? Now, on the right side, we have the slope, which is -5/7. So let's write it down, which multiplies x minus x1. But don't forget that, since we're taking point P in this case, we have x minus x1, and x1 equals -1. In other words, it would be minus -1, but minus -1 is the same as +1. Therefore, that's how we get the equation of the line in its point-slope form. This is it. Well, this is the one we get if we take point P, like I was saying. But if we take point Q, we'll get a different equation. But both are correct. Look, let's take point Q so you can see what we're going to get. So again, we're going to do exactly the same thing, but now with point Q. Come on, let's substitute. I get y minus y1, but in this case, If I'm taking point Q, how much is y1? Well, it's 3. Because this would be x1 and this would be y1. So I get y minus 3. Let's write it down. In this case, it's not going to be negative, right? This is equal to m, which we said is minus 5/7. This one is not going to change, which multiplies x minus x1. But x1 is minus 8. So I end up with x minus 8. But x minus 8 is actually equal to x plus 8. So now we have the equation of the line in its point-slope form. But now considering point Q, these two equations are correct. Either one, in fact, passes through these two given points. So at this point, we would already be finding the two equations. What am I going to do next? Well, I'm going to transform these two equations into the slope-intercept form of the line. So let's see. I'll erase this and transform them. And anyway, we have to end up with exactly the same equation. Look, I've already copied here the two equations I arrived at. And now, let's transform them into their slope-intercept form. How are we going to do that? Let's see. I'll start with this one first. Once we finish, we'll repeat the process for the other one. We must, I insist, get the same result. Here, it's simply about solving for y. So the first thing I'm going to do is carry out the multiplication I have on the right side. So I'm going to multiply negative 5/7 by what's inside the parentheses. And at the end, I'll move the 2 to the other side. So on the left side, for now, I still have y plus 2. Here we have negative 5/7 times x. So I get negative 5/7 x. Then we have negative 5/7 times positive 1. Well, negative times positive is negative. And negative 5/7 times 1 still gives me negative 5/7. Now, we're going to move this plus 2 to the other side as a subtraction. So I end up with y equals negative 5/7 x minus this 5/7 that we already have here. And right here, look, I'm going to move this plus 2 over as minus 2. But I already know that minus 2 is the same as minus 14/7. Right. I mean, I'm converting it to sevenths, so it's easier to work with. So, instead of writing minus 2 that comes from here, I'm going to write it as minus 14/7. Since minus 14/7 is still minus 2, I insist on that. Now I'm doing it this way to make it easier for myself. So here I get that y equals minus 5/7 of x. And here we have minus 5/7 minus 14/7. So in total, I get minus 5 plus 14, that's 17. 19. 19, what? 7/7. Done. This one right here is already the equation of the line in its slope-intercept form. Look, it's the same structure as y equals mx plus b, which we already saw in previous videos. That is, m is minus 5/7 and b is minus 19/7. Well, the same thing I just did here, I'm going to do on this side, and we have to get to the same equation in its point-slope form. All right, let's do it. So here I get that y minus 3 equals minus 5/7 times x. And then here, let's see. Here we have minus times plus, which is minus. This 8 is as if we had it like this. Right, 8 over 1, which is still 8. So here I'm going to put 5 times 8, which is 40. This goes in the numerator. And then 7 times 1, which is 7. You're following me with that, right? Now this minus 3, we're going to move it over as plus 3. So that leaves me with y equals negative 5/7 of x minus 47, which was already here. And we're going to move this minus 3 over as plus 3. But as I was saying, in order to work with those sevenths, it's better to convert this 3 into sevenths. 7 times 3 is 21. So that means that 21/7. 21/7 is equal to 3. You're following me on that, right? 21 divided by 7 is 3, so we still have 3 here. Why did I convert it to sevenths? Because we also have sevenths here. And that allows me to have fractions with a common denominator. So finally, I end up with y equals negative 5/7 of x. And here we have negative 47 plus 21/7. So we do negative 40 plus 21. That gives me negative 19. Negative 19 what? Well, sevenths, that's it. This right here is already the equation of the line in its slope-intercept form, and I want you to notice we're arriving at exactly the same thing, and it's equal to negative 5/7 of x minus 19/7. That's it. With that, we're confirming that what we've done is correct, right? And now we have both equations. Well, finally, I'd like to show you something that I find super interesting. Look, I'm going to bring up this calculator here, or the emulator of this calculator, and we're going to press here where it says Home. Then we're going to scroll down to where it says Table, and we're going to enter this equation. In this case, it asks me to enter it as a function. But for practical purposes, in this case, it turns out exactly the same. So we're going to press here where it says Function, and we're going to scroll down to where it says Define f of x. And here we're going to enter negative 5/7 of x minus 19/7. So I press Shift, minus, and we press the fraction button. We enter 5/7. 5, go down, 7. I move over with the arrow and put the x. Then we have minus, and we're going to press the fraction button again. And we enter the 19, go down with the arrow, 7ths, done. I've now entered the function in this case. We press execute. And now, when I put a -1 for x, it should give me a -2 for y. That is, for f of x. And when I enter a -8, it should give me a 3. With that, we would be confirming that what we did was correct. So let's go ahead and press Shift, -1, we press execute. And it's telling me, look, when x is -1f of x is -2. In this case, I have -1, -2. So everything's good. Now let's put in a -8 shift, -8. We press execute, and it's telling me that when x is -8f of x is 3, and we had this point, which is -8, 3. What does that mean in practical terms? Well, in fact, when I'm entering this equation, which in this case, I insist, would be a function in the calculator, it is indeed showing me that it passes through those 2 points. Therefore, in fact, what I did was correct. If we find the equations of the line, or rather, the equations for this line that passes through these 2 given points, with that, we would also be confirming that what we did was correct. And well, that's it for today. I hope the video was helpful, but above all, that you enjoyed it. If you liked it, please subscribe to this channel. I'm uploading videos every day. See you next time. Take care and behave yourselves. Bye-bye.